I'm Anil Kumar. Welcome to my series on quadratic functions. Now we will discuss how to find vertex of any parabola given its equation. Now there are four different ways of finding the vertex, and as you know, the vertex of a parabola can be a maximum or a minimum value. So we'll discuss how to use these different methods to find vertex. To highlight some particular things which we are going to look into, let me sketch a parabola and then we'll discuss a bit. Let's say that's a parabola. Now clearly in this particular case, let me write a general equation. Let's say y equals to ax squared plus bx plus c. Now for this parabola, the point which we are interested in finding is basically the vertex, which always lies on the axis. This is called the axis of symmetry. So the x value of this point is of our interest to us. So we basically want to find this value, this x value. Okay, let me call this as x1. Now, if you use the quadratic formula, which basically is minus b plus minus square root of b square minus 4ac divided by 2a, in that case you get these 2 points. Let's say these 2 points are let's call them capital A and capital B. In this case, these are the two x-intercepts. So what we get here is basically x-intercepts, as shown here. So the value of x could be found in many different ways. This is one way, this is like midway between them. Correct. So one value of x could be a plus b divided by 2. So which we say is the average value. Now since we found this two values, now these values could be found using a quadratic formula or could also be found by factoring. So these two methods could be used to find the x-intercepts. Which are shown here, and the average value will give us the x value. So as I have shown here, I will call it x1, this particular value. So once you find this value, in that case we know the y value also by substituting x1 in the formula. Correct? Now this method of finding x-intercepts could be used by factoring, but remember all equations cannot be factored, so sometimes we do quadratic formula. So either way. Now the second method here is completing the squares. For completing the squares, that is to say, we need to write this particular equation as y equals to a times x minus p whole square plus q. Now in this case, the x value which I am saying is x1 is equal to p. Perfect. So that gives you the answer with the method of completing the squares. Now the last method here is partial factoring. This is extremely important method and probably one of the best ways of finding the x's. And what we really do here is that we try to figure out the length. We try to figure out for some y value, y equals to basically c, which happens to be a y-intercept. So at this point, when is y equals to c? We could partial factor and then average of these 2 points. So let me call these points as C and D. I mean the x values. C is normally 0, okay, but so the x values. So at the y-intercept, the x value is 0, the other value is, let me say, D. So in this case, we know that x1 is equal to half of D. You get an idea. So if you use this point, then the value is half of D. Now that is the fastest way of really finding the axis equation, right? So what we are given here is the equation of axis. Now we are going to apply what we have learned here using these 4 different equations. Now let's see and try to understand how to work with this, right? So this is our x-axis, this is the y-axis, and if parabola is opening downwards, we know we have maximum in this case, right? Minimum will be when the leading coefficient is positive, as it is in the very first case. So now let's take up these equations one by one and find the maximum and minimum values. Okay. Now let us apply the quadratic formula and find the vertex of the parabola given by the equation y equals to 2x squared plus 4x minus 1. So let me rewrite the equation, which is y equals to 2x squared plus 4x minus 1. The quadratic formula is that gives you the roots x equals to minus b plus minus square root of b square minus 4ac divided by twice a. Now in the given equation we know b is equals to 2, b is 4, a is equals to 2, and c is equals to minus 1. So we are going to substitute these values. So when we substitute these values, we get x as equal to minus 4 plus minus 4 squared minus 4 times a, which is 2, and c, which is minus 1, divided by 2 times a, which is 2. It is a good practice to write a first. Okay. Now here we get this root as minus 4 plus minus square root of 16. Minus and minus makes it plus. 4 times 2 is 8 over 4. Okay, so let's simplify this and rewrite. So what we get here is the x-intercepts equal to minus 4 plus minus square root of 24, that is 16 plus 8 divided by 4, or we could write this as minus 4 plus minus 24 is 6 times 4, so we could write 2 square root 6 over 4. Now dividing by 4 we get minus 1 plus minus square root 6 half of it. So that becomes your roots. So what I'm trying to show here is that we got the 2 roots. Now if you sketch this parabola, which is opening upwards, so let's do it. So we'll just make a very approximate sketch. Y-intercept is minus 1 and we know the 2 roots. So the parabola will be kind of like this. Oh, I'm sorry. Not this at all. The vertex is not here, but okay now. So this value here basically is minus 1 minus square root 2, square root 6 over 2. And that value is minus 1 plus square root 6 over 2. So the axis is somewhere in between, right? So this sketch is not very accurate. So the axis, let me write axis. is halfway between these two values. That is to say, will be at x, let's say x1 equals to the x's we are talking about to get the vertex, is you add them up, which is minus 1 plus square root 6 by 2, and also you add minus 1 minus square root 6 by 2, and then you do half of this. So when you do this, what you really notice is that these two things cancel, right? So what you get exactly here is that you get this as equals to minus 2 over 2, and the axis is at minus 1. So this diagram is not really correct. The y-axis will be somewhere here. Okay. So, so what you notice here is that this axis, let me now make it with a different ink. Okay. So the axis here is at minus 1. Do you see that? So we could write the x equals to minus 1 as the axis, right? You will notice that this value of minus 1 basically corresponds to x equals to minus b by 2a. Perfect. So this particular value, so that gives you the axis, which you can see very clearly from the quadratic formula and our calculations. Minus b by 2a. So this is minus b by 2a. So if I apply minus b by 2a, so we get what? We get the same value. Let me show you here. Minus of b is 4 divided by twice 2, which is minus 1. So that is the shortcut. Let me write down. Since the other terms, which are the plus minus terms, they cancel. Okay. Now, at x equals to minus 1, let's find the y value. So y equals to 2 times minus 1 square plus 4 times minus 1 minus 1. So which is minus 1 square is positive 1. So 2 minus 4 minus 1, which is 2 minus 5 or minus 3. So we get this maximum, or we get the vertex is at x equals to minus 1, y equals to minus 3. So in this particular case, what we note is that the maximum, we have the minimum value. So the minimum is at x equals to minus 1, and the value of minimum equals to minus 3. So that gives you the value which is at minus 1 minus 3. Correct? So of course we'll get minimum here since the parabola opens upwards. Perfect? So that is how you could find it, and here is a shortcut. You could straight away apply this formula, x equals to minus b by 2a, to get the x value of the axis and substitute the value to get the y value, which, if the leading coefficient is positive, leads to a absolute minimum. Perfect. Now let's see the other method. Now we are going to apply the method of factoring to find the vertex. We are given the equation y equals to minus 5t squared plus 20t plus 25. Now these type of equations you must have seen while solving problem of distance and height when a ball is thrown under the acceleration of gravity, right? So let's factor minus 5. We get t squared plus becomes minus, when you factor this, dividing 20 by minus 5 gives you 4. So 4t, and here we get minus 5. I have taken simple equations to illustrate the point how to find the vertex. We're looking for product of minus 5 and sum of minus 4, so that will be t minus 5 times t plus 1. So we get two x-intercepts. So the x-intercepts, I should not call these intercepts with t values, right? So let's find the intercepts now. And we'll call them t-intercepts. Since if I sketch this parabola, what do I get? Let me just sketch it here. So the y-intercept is 25, so it is something like this, right? So, and it falls kind of like this. Since on the independent axis we have time t, and that is the y value. So the t-intercept here is at 5, and the other point we get by extending, which is at minus 1. So clearly the axis here, right in the center, is midway between them, right? So now we get the axis as, now the t-intercepts are at t equals to minus 1 and t equals to 5, clearly as shown here. So the axis is average value, which is minus 1 plus 5 divided by 2, or we can say 4 divided by 2, which is at 2. So this equation is t equals to 2. Now to find the y value, we'll substitute 2. So y equals to minus 5, 2 square plus 20 times 2 plus 25, correct? Which is minus 5 times 4 plus 40 plus 25, okay? Which is minus 20 plus 40, that gives you 20, and this is 25, so we get 45 as our answer. So this point here is 45. Now since we have negative here, so parabola opens down, so we have a maximum, and the vertex is at 2, the t value, and 45 is the maximum value, correct? So that is how you could actually find by completing this so that is how you could find the answer by factoring. You should remember that it is not very easy to factor all the quadratic equations, correct? Now let's look into the next example. Now we will understand the third method to find the vertex for a given quadratic function. We are given y equals to 2x squared minus 8x plus 1. These steps are kind of like this. First is factor the leading coefficient from the first two terms. We just factor 2, and what we get here is x squared minus half of 8, which is 4x. And we are going to keep this 1 aside. This is very important. Now the second step is to complete the squares. How can you do that? To complete the squares, we do half of 4, which is 2, and we add and subtract square of that number, half of 4. So when you add and subtract square of half of 4, in this case, you don't really change the equation because you're adding and subtracting the same number. Now, the first three terms form a perfect square. This is like a square minus 2ab plus b square. Perfect. That's the whole idea. So from here we get x minus sign comes from here, 2 from there. And if you square this binomial x minus 2, you get the first three terms. Now here we have minus 2 squared, so I'm writing this as minus 4 plus 1. Now we will open the bracket. So when you open the bracket, 2 gets distributed. So we get 2 times x minus 2 whole square minus 2 times minus 4, which is 8, plus 1. And now we have to combine these two to get the answer, which is 2 times x minus 2 whole square minus 7. So that is called the vertex form of our equation, right? So we get the vertex form. Now from here, we can easily read the vertex. We can also describe the transformations, and we can sketch the graph. So all the things can be done at this stage. Okay, so let me just, since we have vertex, let's write down. We have vertex, which is 2, y value is the, in this case, the minimum of minus 7, right? So 2 minus 7 is the vertex. So we could kind of sketch this. Positive 1 is the y-intercept, so I'll just start with this and then go up like this. So the idea here is to work for the accurate value of the vertex. So this value here is at 2 and the y value is minus 7. Perfect. So at x equals to 2, we have minimum value minus 7. So that is how we use completing the squares method to find the vertex. This is most versatile and most effective way of finding the vertex for any quadratic equation. Now let me share you my most favorite way of doing it, which is partial factoring. Now let us understand how to find vertex using partial factoring. The equation given to us is y equals to 3x squared minus 6x minus 2. You will realize the beauty of this method once we complete this part of the video. Now since this is negative is the y-intercept, let me sketch the axis slightly above, and that is a parabola which opens upwards. So let's go like this. Okay. So that becomes the parabola for us. Now what do you realize? That if I draw a horizontal line right there, for example, this line will be y equals to minus 2, right? This horizontal line. And this line intersects the graph at 2 points. One is when x is equal to 0. The other value is this one. So we call this value d initially, right? Now that value, if you figure out, then what is the axis? Axis is midway between 0 and the value d. So we could write this equation here as x equals to capital D by 2. You get an idea. How do we find d? See how easy it is. Let us use only the first two terms of our quadratic equation to factor. The two terms are 3x, right? So if I factor 3x, I get x minus 2, and that is minus 2. Correct? So we get y equals to this. So here we get y equals to 2. So y equals to 2 when x is equal to 0, which is because of this, right? And also at x equals to 2, and also at x equals to 2. So in our case, this value here is at 2. So what is the axis? So the midway is what? Midway is the axis. So we get the axis, which is 0 plus 2 divided by 2, or just 1. So in our case, x equals to 1 is the axis. So this is, in fact, the fastest way of getting the vertex. I hope that is absolutely clear, right? And it's easy to find the y value. You could calculate y value as y equals to, substitute 1 here, 3 times 1 square minus 6 times 1 minus 2, which is 3 minus 6 minus 2, and that is equal to minus 5. So we get this point, vertex, at x equals to 1 and y equals to minus 5. Is that clear? So what we learned here are 4 different ways of finding the vertex for given quadratic equation. So the best way I will say is partial factoring as shown here, and of course you could always say that x is equals to minus b by 2a. So that is directly from the formula which can be applied to get the x's. Once you do that, you can substitute this value into the equation to get the maximum or minimum value as the case may be. Remember, if the leading coefficient is positive as it is here, you will get absolute minimum value, and if the leading coefficient is negative as it was when we had equations with time, right, so in that case we get a absolute maximum. I hope this video gives you good insight of finding vertex for a parabola. Now this is very important since the vertex also signifies optimum value for many application questions. I hope you have enjoyed this journey of learning about how to interpret a quadratic equation. Feel free to share your views and your suggestions, and if you really like and subscribe to my videos, that would be great. Thanks for watching and all the best.